Welcome to Molecular Chaos. Today we're surfing our way through electromagnetic waves. So let's jump on in. Hey guys, welcome back to Fun Facts with Jasmine, where I tell you facts and obviously make it fun. Today, we'll be learning about the electromagnetic spectrum. I know, that's kind of a big word, but believe it or not, it's all around us. Let me break it down. The spectrum looks something like this. And it's divided into 7 main groups: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Don't worry, guys, I'm going to explain all of them. Starting with radio waves. They have long wavelengths and low frequencies. It looks something like this. It's perfect for transmitting AM and FM radio and TV signals. Next on the spectrum is microwaves. They have a shorter wavelengths and higher frequency than radios. It looks something like this. Microwaves work to heat food in a microwave. Go figure. It's also used in wireless communication like Wi-Fi. I think it's time for our first fact, guys. Fact number 1, did you know GPS systems use radio waves to help us find directions? Fact number 2, radio waves are the longest waves in the electromagnetic spectrum. They can travel very far, which is why radio and TV and cell phones use them to send signals. But back to the spectrum. Next is infrared. The waves look something like this. These waves are basically heat. Whether it's sunny day or you're sitting by a warm fire at night, infrared signals are even used for remote controls to control the TV and other devices. Next in the spectrum is visible light. It looks something like this. This is what helps us see billions of colors. This is the only part of the electromagnetic spectrum that we can see. Time for some more facts. Fact number 3, even though the light is the fastest moving thing in the universe, it takes about 8 minutes for the light from the sun to reach the Earth. That just goes to show how far the sun really is. Fact number 4, infrared is used in night vision cameras so people can see in the dark. Some animals can see naturally in the dark, like some snakes can see heat, helping them find prey in the dark. But next on the spectrum is ultraviolet. The waves look something like this. Next we have also known as UV radiation. People often use them in tanning beds, but too much UV rays can cause sunburns and be harmful if you are exposed for too long. Next, we have X-rays. They look something like this. X-rays help us look inside objects in living tissue, aka our bodies. They give us a better look at broken bones. I would love to see an X-ray of all my bones. How about you? X-rays are also used at the airport to see inside luggages. And finally, we made it to the end of the spectrum. The last one is gamma rays. They look something like this at the very end. They are the shortest one on the spectrum, but have the highest frequency. It comes from radioactive sources. They are used in medical treatments, mostly cancer therapy, and it's used in space to help us learn more about the universe. Now that we got through the spectrum, here's fact number 5. Cats can see a bit of ultraviolet light. So can bees and butterflies, unlike humans. Sometimes flowers have a special pattern that only bees can see. I wonder what that pattern looks like for them. Fact number 6. Even though space looks really dark, it's actually filled with all kinds of electromagnetic waves, like radio waves, infrared, and X-rays coming from the stars and galaxies. Fact number 7, did you know bananas give off a tiny amount of gamma radiation because it has potassium? Don't worry, guys, they're still very much safe to eat. Fact number 8, did you know if we were able to see the entire electromagnetic spectrum, our worlds would look completely different. We'd be able to see heat, radio signals, and radiation everywhere. I definitely wonder what that would look like. I also feel like it would be a bit too chaotic for my liking. Well, that's all the facts I have for you guys today. I hope you learned something today. See you next time on Fun Facts with Jasmine. Bye.
Hi, welcome to Learning with Leslie. Today we're talking about the electromagnetic field. What is an electromagnetic field? It goes from tiny waves together to big swooping waves, and there are 7 of them. Humans can only see a very small portion of those. In the middle of our spectrum, we see what is called the rainbow, and when you see in the sky after it rains, those are all of the lights that we can see. Ultraviolet waves are just outside the human spectrum, but many of our furry friends, as Jasmine was talking about, can see them. Has anybody had an X-ray before? This is a machine that takes a photo of your bones. It's called ionization radiation, which means its energy levels are so high that when it strikes a molecule, it can remove an electron, forming an ion. These are a lot of big words. And because of this, exposure to X-rays should be limited. Have you seen a rainbow before? That is the entire spectrum of light that humans can see. Blue is the shortest wavelength, and red is the longest wavelength that people can see. Other things that we can use that have electromagnetic fields are microwaves. 5G also uses waves, so when you're using your phones or your internet, and TV remotes use infrared to connect to the TV. What else can you think of that uses electromagnetic waves? As we talked about, waves have different sizes. They go from big swooping waves that are radio to very small little waves that are the gamma rays and everything in between. But like Jasmine says, we can't see any of those. It would be kind of funny if we could see our microwaves working or our bones being X-rayed, then we wouldn't need these machines. All right, that is it for today. Thank you for joining me.
All right, Chaos crew, welcome back to Chaos with Kazi, the part of the show where science gets a little weird and honestly, sometimes a little dramatic. Today we're talking about something huge, the electromagnetic spectrum, which sounds like something that would shoot out of a robot's chest. But actually, it's just the giant family of energy waves moving all around us right now. Radio waves, microwaves, heat, visible light, ultraviolet light, they're all the same type of energy, just different wave sizes. Some waves are really long and some waves are really tiny. And humans can see a very small part of this giant family, which is visible light, which means most of what's happening around us is invisible, which it feels a little suspicious, but also very chaotic. So right now, these lights look normal, nothing special, just regular light. But it doesn't just travel just like a straight beam. Light behaves like a wave. And waves bend and spread and change direction, which means we could actually change how light looks, using science. And slightly ridiculous glasses that I have here. So, take off my glasses and put on these. Woo! So, these lenses have tiny patterns inside them that bend light as waves of light pass through them. This bending is called diffraction, which is just a science way of saying waves that are spreading out. Let's see what happens. It feels very emotional for a physics lesson, but the light didn't itself change. Only the waves reached our eyes that changed. The lenses are guiding us guiding the wavelengths into a new pattern. So instead of just one point, we see a shape. Because of the light behaves like a wave, and because that matters so much, light is just one tiny part of the spectrum. And different wavelengths create different types of energy. Longer waves become radio waves. Slightly shorter waves become microwaves. Shorter but still becomes infrared, which we feel as heat. And then visible light, the ultraviolet light, which we cannot see at all. Same energy, same family, just different wave sizes. So let's try a different pair here. I'm gonna put these over my glasses now. So, because different patterns affect the waves in different waves, these lenses have a different tiny pattern built into them, which means the waves spread differently. Let's see. Ooh, pretty butterflies. Now, I love how these lights look like butterflies, which makes the universe feel unnecessarily artistic, but at the same time, it's the same science. The grooves inside the lenses are redirecting the waves of light, changing how the waves overlap and changing what shape that hits our eyes. We are literally watching light waves behave, which means light isn't just brightness. It has structure and shape. And wavelength helps us decide where energy belongs on the electromagnetic spectrum. So, one more pair, because chaos demands comparison. Woohoo! These ones are repeated points of light. So instead of just light from a source, we see many versions of the same light spreading outward. Woohoo! So now we can see the waves are spreading in multiple directions, and light doesn't just travel straight. It moves like ripples, and those ripples are part of something much bigger. The electromagnetic spectrum is basically a full range of wave sizes that energy can have. So let's recap. Radio waves are the long ones. Microwaves are shorter. Infrared is even shorter. Visible light is even smaller. If ultraviolet light is smaller. And then different wavelengths are just different effects. Same type of energy, which means the light helping us see right now is related to the waves that heat food, power radios, and reveal invisible parts of the universe. So, science is basically discovering that reality is doing way more than we notice. And honestly, that feels pretty chaotic. I'll see you next time on Chaos with Kazi.
This has been Molecular Chaos.
Episode 5.
The electromagnetic spectrum.
Have fun.
Keep learning.
And stay chaotic.
See you guys next time.